This meeting is being recorded.
In Chapter 10, Problem 16, we are asked to predict the monobromination product that will be expected, or products, right? So we're told that we might have more than one here, if we use the NBS reagent. So if you recall, that promotes allylic bromination, monobromination, because we keep the concentration of, bromine radicals, and HBr at a low concentration. So monobromination is promoted when we use N-bromosuccinimide, NBS, and irradiate it with UV light. So let's take a look here and see if we can predict what our possible products would be. So first, let's look for any of those allylic sites. So allylic sites. So we have our double bond. So at the end of a connecting single bond, we would see an allylic site here. We would see one here going the other way. And then we can see down here, we would have these two sites down below are also allylic sites. So theoretically, if we had a CH bond present, any of these sites could be brominated through this process. But these top two, we don't need to consider because these are quaternary carbons and they do not have any CH bonds available, so we cannot abstract a hydrogen there and promote bromination. So we're limited to just these bottom two sites. And if you notice, this molecule has a plane of symmetry. So really, we're just going to focus on this one allylic site that I'm circling there. So let's see what happens if a hydrogen is abstracted at that site. We'll come down here and notice that we have the radical drawn in on that bottommost, leftmost carbon there, so that primary radical. And let's draw the fishhook arrows that would generate the resonance structure. So this electron can move in here. One of the I bond electrons moves over, and then we create this double bond there. And the other electron in that pi bond would be moved over here. So that's where we generate that tertiary allylic radical site. So first we had a primary. Over here we would have a tertiary radical after resonance, after movement. So now we have these two sites to brominate. So again, let's look at what would happen with the primary. So let's draw the bromine down here. So we would add right here from the radical, that was the primary site radical on the left. And then over here, our tertiary site would produce this compound. So you can see that these are monobrominated products, both of these up here. And due to that resonance stabilized allylic radical, we can have two products form.